In a 200 amp square D home line distribution panel, it is not acceptable to mix bare ground wires and neutral wires on the same ground bus, or vice versa on the neutral bus. Even if both buses are bonded to ground, maintaining a clear separation between the grounding and neutral systems is crucial for electrical safety and compliance with the National Electrical Code. The neutral conductor, also known as the grounded conductor, carries current back to the source under normal operating conditions. The equipment grounding conductor, or ground wire, provides a low impedance path for fault current to return to the source, allowing overcurrent protection devices, such as circuit breakers or fuses, to quickly trip and energize the circuit in the event of a ground fault. When ground and neutral wires are mixed on the same bus, it can create a parallel path for neutral current to flow through the grounding system. This can result in several potential problems. Firstly, stray voltage can appear on the equipment grounding conductors, which can create a shock hazard if someone comes into contact with grounded metal parts. Secondly, the increased current flow through the grounding system can cause electromagnetic interference, which can disrupt the operation of sensitive electronic equipment. Thirdly, it can interfere with the proper operation of ground fault circuit interrupters, or GFCIs, which are designed to protect against ground faults. The National Electrical Code, or NEC, specifically requires the separation of grounding and neutral conductors except under very specific circumstances, such as at the service entrance or at the source of a separately derived system. These are a few reasons that the code requires keeping the ground separate from the neutral. Firstly, to prevent unwanted current flow on the ground conductors. Secondly, to ensure proper operation of safety devices. Thirdly, to reduce the risk of electrical shock. In a typical residential electrical system, the neutral conductor is bonded to ground at the service entrance, which is usually at the main electrical panel. This bonding point provides a single point of connection between the neutral and grounding systems, ensuring that all grounded metal parts are at the same potential. Downstream from the service entrance, the neutral and grounding conductors must be kept separate. This means that in subpanels and branch circuits, the neutral conductor should be connected only to the neutral bus, and the grounding conductor should be connected only to the ground bus. The equipment grounding conductors must be properly sized according to the overcurrent protection device protecting the circuit, as specified in NEC Table 250.122. This ensures that the grounding conductor has sufficient capacity to safely carry fault current back to the source. The neutral conductor must also be properly sized according to the calculated neutral load, as specified in NEC sections 220.61. Common grounding mistakes to avoid include firstly, connecting ground and neutral wires together in subpanels, secondly, using the metal conduit as the only grounding path without supplemental grounding conductors, thirdly, not properly bonding metal enclosures and equipment. If you are unsure about the proper wiring of your electrical system, it is always best to consult with a qualified electrician. An electrician can inspect your system and ensure that it is wired correctly and safely, and can also provide advice on how to improve the safety and efficiency of your electrical system. Always follow the local electrical code requirements when installing or modifying electrical wiring. Improper wiring can create a significant safety hazard. Remember, working with electricity can be dangerous, so always take the necessary precautions and consult with a qualified professional if you have any questions or concerns. It's important to ensure that all electrical work is performed in accordance with the National Electrical Code, or NEC, and any applicable local codes. This includes proper grounding and bonding techniques to minimize the risk of electrical shock and fire hazards. Also make sure that the grounding system is properly installed and maintained. This includes ensuring that all ground connections are tight and free of corrosion, and that the grounding electrode system is properly sized and installed in accordance with NEC requirements. Periodically inspect the electrical system for any signs of damage or deterioration, such as cracked or frayed wires, loose connections, or corroded components. If any problems are found, they should be repaired promptly by a qualified electrician. When working on electrical equipment, always de-energize the circuit before beginning any work. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Use a voltage tester to verify that the circuit is de-energized before touching any wires or components. Wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and insulated tools when working on electrical equipment. This will help to protect you from electrical shock and other hazards. Never work on electrical equipment when you are wet or standing in water. Water is a good conductor of electricity, so it can increase the risk of electrical shock. Be aware of your surroundings when working on electrical equipment. Make sure that there are no flammable materials nearby, and that you have a clear path to escape in case of an emergency. If you are not comfortable working on electrical equipment, or if you are not sure how to do something safely, it is always best to call a qualified electrician. Electrical work can be dangerous, so it is important to take the necessary precautions to protect yourself and others. Proper grounding and bonding is an essential safety feature of any electrical system, helping to prevent electrical shock and fire hazards. Ensuring that the grounding system is properly installed and maintained is crucial for the safety of yourself and others.